In this section, we're going to explore scalability design concepts and principles that enable us to meet our growth requirements. We're going to do this by focusing on elasticity initially, in other words, services that can more closely align to our needs. And finally, we're going to take a look at the capabilities that are available in the cloud that enable us to be able to meet our growth requirements over time. Let's begin by exploring elasticity. Elasticity can be used to describe a scenario where systems or machines are added or removed based on requirements, in other words, to meet end user demands. And one of the benefits of elasticity is the fact that we end up paying for machines that are in use, and in so doing, we're optimizing our costs. When migrating to the cloud, it is important to note that the cloud offers a much higher level of automation, and the administration tools available on the cloud are significantly more advanced than what's typically available on premises. Therefore, while in an on-premises environment, it may make sense to provision fewer larger systems or larger machines in order to minimize the administrative burden. In the cloud, there's a lot more value in provisioning a larger number of smaller machines and taking advantage of the capabilities that the cloud offers to automate the administration of these machines. Working with smaller servers or machines enables us to increase or decrease capacity in smaller increments. And the reason elasticity is so important is because it enables us to accommodate growth requirements without impacting service delivery. Let's have a look at the capabilities that enable us to deliver elastic services in a typical cloud environment. The ability to create a template that represents the configuration of machines is a common requirement. And once the templates are created, they are used to create groups of identical machines or servers. These groups of identical machines or servers are then configured to auto-scale. Health checks are also configured in order to ensure that end user requests are only routed to machines that are available and have sufficient additional capacity. And the routing of requests is typically performed by a load balancer, and these requests are typically routed to backend services. And cloud providers generally offer a range of configuration options for creating and managing backend services. This concludes our discussion on scalability options in the cloud that enables us to meet our growth requirements. In a subsequent module, we're going to demonstrate how these capabilities can be implemented and used to scale compute resources.